Hello.
Yeah. Hi.
Hi, Hannah. Can you hear me?
Yeah, I can hear you.
Am I audible and visible?
Yes.
So that's your mom.
Yeah. Hi.
Hello, Evelyn.
Hi.
Hi. So my voice is crystal clear to you.
Yeah.
Before I start, Hannah, do I have permission of both of you to record the video for my YouTube channel? Is that okay?
Yes. Yeah. Yeah.
Okay. Now, Hannah, it's like that I'm going to teach you the same topics, okay, that I taught Sharon, so that both of you can discuss and see uh, potential joining of the group. All right. If you want to join, that will be fair enough. If you're not interested in joining, please drop a message, and I wish you all the good luck for that. All right. So I'm going. Before that, do you have any questions? Your mom has.
No.
Your mother can
No,
sit
no.
throughout the demo, no problem. You can bring anyone who wants to sit for the demo. I have no problem. Absolutely. Okay.
Yeah, it sounds good. Yeah.
Right. So we'll leave the formality for later on. If in case you decide to join, then we'll go for how am I going to teach, etc., etc. Today I'll focus on the demo video, right? And
Yeah.
what you're supposed to do is you're supposed to hear me, look at the board, and just listen. All right. I'll take you to
Yeah.
the topics that you've already asked me to provide the demo for, right? Once I'm through, I'll ask you questions that if in case you have questions. During the teaching process, if you have a question, keep your mic unmuted throughout. It's one on one, so no disturbance from mine or your side. If in case we have some internet issues, either side, okay? Don't worry, we'll just connect on WhatsApp and rejoin. All right, there should be no issues. If in case we have, we'll not end the session abruptly. We'll connect on WhatsApp and again we are going to join and finish off the session. All right. If in case I teach students, what the process that I follow is I ask them to see the board. I provide them notes thereafter. If in case they do not have any questions, we go for like question answer round. Then the notes. The notes have to be written by you. All right. I will dictate or provide notes. You have to put it down in your own handwriting because more you practice chemistry, the more expertise you're going to have. If you read chemistry, you will never learn chemistry. So write and practice. That's very important, especially when we talk about organic chemistry, right? And once that is done, you have your textbook with you, right? I'll ask you to use a pencil or a highlighter and mark whatever is important, right? So that's how I teach students online. First, just lecture method. I can use presentations, I can use notes, whatever I want to. Thereafter, you have questions, you ask me, clear all your doubts, right? In middle of lecture, you can ask me n number of times that, ma'am, I did not understand. All right. But once the lecture is completed, you have no doubts. And next day, I ask you questions from the same topic, and you are not able to reply, I am going to scold. All right. Evelyn, do I have your permission to scold your child?
Yeah.
All right. Right. And the scolding, what I scold is 2 days you will not use your phone. That's all. That's the punishment. That's all. Nothing else. Nothing. No torture. Nothing else. You have to hand your phone to your mama. 2 days without phone, no connectivity. That's all. All right. Shall I begin? I'm going to present my screen, right? You'll be able to see something. Let me know if that is clear or not. All right. Can you see a board, whiteboard, Hannah?
Yeah, I can see.
All right.
Yeah.
Now you're going to check the font. Is this font okay?
Yeah, it's good.
It's good? Right.
Yeah.
So we begin with the topics, right? Shall I begin?
Yeah.
All right. Now look, this is basically the chapter which is going on in your school, right? This is chapter 8, compounds of carbon. This is the topic that you've asked for demonstration. right? I am going
Yeah.
to take you to these topics, but before that, we are going to talk about these also as recap. Maybe you know the topics, or maybe you need to brush up, but I'm going to sail through these topics so that when you reach this one, these topics become more clearer to you. For these topics,
Yeah.
the background or these topics are required. Fine. So we begin with hydrocarbons. Then we'll talk about types of hydrocarbons and we'll focus on alkanes, where I'll teach you naming of alkanes, how to draw their structures, and then the topic for demo. What are straight chain hydrocarbons? We'll take alkanes as examples. What are branched hydrocarbons? Again, alkanes as examples. And then we'll also discuss what are isomers. So we'll wind up the lecture at isomers. Am I clear?
Yeah.
All right. So to begin with, let's go for what are
I think
hydrocarbons?
I think I'm doing a different topic to Sharon though.
Uh, all right. This is what Sharon told me. I mean, this is what I've given demonstration, and I asked her mom to confirm from you. Doesn't matter. We'll take up to the next stop. It doesn't matter.
Okay.
Okay.
Yeah.
We talk
You
about
don't have to.
hydrocarbons, right? So let me put up more of
Mm.
questions, right, to you because you already know the topic maybe. Now, if you talk about hydrocarbons, you can see from the name itself, it is made up of two words, hydro, that comes from hydrogen, and carbons
Yeah.
from carbon. So I'm going to abbreviate it as H oblique C, hydrocarbon. Some people also abbreviate it as small h and C. We'll follow this one, H for hydrogen and C for carbon.
Okay.
Now, hydrocarbons, there's history about hydrocarbons that you probably would have studied. What is organic chemistry? What are organic compounds? Why we have millions of compounds of carbon? All these you must have already studied, right? Now, hydrocarbons, depending on whether we have a carbon-carbon single bond or a carbon-carbon double bond or a carbon-carbon triple bond. Fine. They are classified into alkanes, right? Alkenes and alkynes. I'm putting a star mark on alkynes because alkynes, as per your VCE, they are extra topic. So we have alkynes. They are given in blue box of your book, written as extension, right? So this is an extra topic. If you are able to study it, it's good for you. Otherwise, you're not going to be evaluated on the basis of alkynes. This is what your VC says, right? Now,
Yeah.
these are called as saturated hydrocarbons. We'll talk about what does it means. And these two are clubbed together and called as unsaturated hydrocarbons. To understand what we mean by saturated and unsaturated, just remember carbon. Carbon has an atomic number 6 and an electronic configuration 2, 4. You know this? Do you know this, Hannah?
Yeah.
All right.
Yeah.
So carbon has four hands, four valency. It can bond with 1, 2, 3, and 4, four hands. That's called valency. It's tetravalent. Clear? Now, if all the hands of carbon, let's replace hands with chemical word, if all the valencies of carbon are satisfied by single bond, let's say it this way. In methane, carbon has no hand to hold on to other atoms. What does that mean? Let us talk about Hannah. Hannah has two hands. In one hand, she's holding a book, and in the other hand, she's holding a glass of water. So both her hands are saturated. She cannot hold any other thing, right? So we say all four bonds of carbon are satisfied by single bond. That is called saturated hydrocarbon. And the class of hydrocarbons are known as alkanes. We focus on this word ane, right? They will have carbon-carbon single bond. Now look, very important thing. If this carbon has one single bond here, how many free valency this carbon number 1 has? One, two, three. Is that clear?
Yeah.
Hannah, is that clear?
No.
No. All right. All right. So, did you read about catenation?
No.
No or yes?
No.
Okay. I mean, Sharon knew that. Doesn't matter. Doesn't matter. Okay, let me explain then. Let's forget about this. Carbon has four hands. I told you this: one, two, three, and four. This hand of carbon is bonded to this carbon, right? So,
Right.
how many valencies this carbon has still has? One hand is bonded with this carbon atom, second, third, and fourth. Now, this carbon's hand are bonded with hydrogen, but this
Yeah.
carbon's hands are free. They are not bonded with any other atom. Such valencies which are not bonded are called as free valencies. See, if we do not know this concept, it will be difficult to go further. These are called free valencies. Doesn't matter. Free valencies. This also has free valency. And how do we show these free valency? These. If this is carbon, right? Now you will tell me, doesn't matter. I have double bond C. Carbon has to have four hands, four valencies. This carbon has one hand bonded to carbon number two, another hand bonded to carbon number two. Now you tell me, Hannah, how many free valencies this carbon number one has?
Two.
Very good. See, you got that? So, but whichever topics are not clear, let me know. I thought you were knowing this. Okay. So we have one, two, three, and four. I'm showing them as free valency. Why free? They are not bonded with any other atom. They are free to bond. That is why they're called as free valency. Now tell me, what about this carbon number two? How,
Two as well.
how many?
Two.
Two. Okay. One is here, three and four. Right? You've done the chapter of bonding, right? Is that completed in your course, in your syllabus in school?
No.
Bonding is not done. All right, then
Mm.
it will be little different. Doesn't matter. For the demo, I'll take you from here. Otherwise, when you join fresh, I'll explain from catenation how atoms form bond, etc., etc. But right now, did you get this? What I've taught you?
Yeah.
Okay. So what you're going to do is I'm going to take another book. So we said alkanes are saturated hydrocarbons. Now you understand what does it means? It is going to
Yeah.
have carbon carbon single bond, right? Or
Yeah.
this is carbon carbon single bond here, or carbon hydrogen single bond. That's all, like this way, right? If you have a hydrocarbon which has a carbon carbon single bond, at least one, you have a compound which has at least one carbon carbon single bond, we call them saturated hydrocarbons. Did you understand this much?
Yeah.
Right? For example, now you will tell me how many free valencies this carbon number one has?
Three.
Three. Very good. And carbon number two?
Three as well.
Three. Right? Now, if a teacher asks you, why is ethane? Forget about how we named it. Just remember formula ethane is C2H6. Why this compound is saturated? What we are going to do is we are going to prove that it has at least one carbon carbon hydro a single bond. So see here. Now three valencies are free here and three valencies are free here. It has to form bond with some atom. The atom which is given is hydrogen. How many? Six. So one hydrogen comes here, second comes here, third here, fourth here, fifth here, and sixth here. Since this compound has carbon-carbon single bond only, we call them saturated hydrocarbons. Again,
Mm.
methane, C, hydrogen, 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 and hydrogen. So you might say, or you might ask a question, it doesn't have a carbon-carbon single bond. I said or it has a carbon-hydrogen single bond. We call it as saturated hydrocarbon. Why? All its four valencies are occupied. They are combined or bonded with another atom, that is hydrogen. And such group of hydrocarbons are called as alkanes. Is that clear?
Yeah.
All right. Now you have unsaturated hydrocarbons also. I will just touch this topic and in detail thereafter I'll take up alkanes. I'll only touch this topic unsaturated. All right. So let's talk about unsaturated. Don't worry, everything will become a little clearer as you proceed in the chapter. Unsaturated hydrocarbon. They say unsaturated hydrocarbons are compounds of hydrogen and carbon which have at least one. The main word is at least one carbon carbon double bond. Now you tell me how many free valency this carbon number 1 has?
Two.
2. I'm repeating this why the free valencies because once you draw isomers and the structures, if you're not clear with the valencies, you cannot proceed ahead. And this one also 2. Or
Okay.
they can have carbon carbon single bond, right? So how many free valency this carbon has? 1, and this also has 1. So if you have an organic compound which contains at least one carbon carbon single bond or carbon carbon double bond or carbon carbon triple bond, we call them unsaturated. Why? Because see, one bond is there as single bond, another bond is between these two carbon which can be broken to form single bond. This is a little complicated. Let me explain. Like you are holding your friend's hands, right? Two hands of yours, and you're holding two hands of your friend. Let us say another friend's come into picture. She said, "Kindly hold my hand." Can let's say it's the bond is between you and me. We both are holding each other hand. Suddenly, your mother also comes, says, "I also want to hold your hands." Can I just leave one of my hand and hold your mother's hand? Similarly, you can leave one of your hand and then hold on to your mother's hand. Can you do that?
Yeah.
You understand? Let me draw and show you. We are here. This is me, let's say S, and this is Hannah, let's say H. We are holding hands. This is my hand. These are your hands. Let's your mama also comes into picture. She said, "I also want to hold the hand." I can leave this hand and hold like this. You can
Yeah.
also leave one of your hands and hold like this. You can use this bond, right? And form more bonds. This was carbon carbon single bond. All bonds were occupied and bonded with hydrogen. If suppose another hydrogen comes into picture, carbon has only four hands. It cannot form bond. It cannot give its free hand. Why? Because there are no free hands. Here, this carbon-carbon double bond can break open and form single bond. So it still has a chance to hold on to any other more atom if reaction conditions permit. Therefore, these are called as unsaturated. You will understand this when we do reactions of unsaturated hydrocarbons. Clear? So these are called
Yeah.
unsaturated hydrocarbons. And if you have at least one carbon-carbon double bond, they are called as alkenes. So whenever you see the word ene, it means there has to be at least one carbon-carbon double bond. And if you have at least one carbon-carbon triple bond, they are called as alkynes. Fine. Is this much clear to
Yeah.
you?
Yeah.
All right. So alkynes, I'm putting a star mark because they're additional topic. Alkenes are the second topic. And number 1 are your alkanes. So in details, I'm going to teach you alkanes. Is that clear? Shall I move ahead?
Okay. Yeah.
Okay. So begin with alkenes. Now listen very carefully. Wherever you do not understand, stop me. Okay? Let's begin with alkanes. I told you alkanes are going to have carbon-carbon single or carbon-hydrogen single bond. Three valencies free this. Next, coming on to general formula. What is general formula? Do you remember the general formula of alkanes? Hannah, do you remember?
Uh,
Huh?
no.
No. Up. Which topic is going on in your school currently?
Um,
Remember? Okay, doesn't matter. I'll teach you the
currently,
general formula. It means I probably we there was a little bit of misunderstanding. Probably hydrocarbons are not going on in your school.
no.
Am I correct?
Yeah, you're
So,
correct.
all right. So, but you're still able to understand because this is exactly the topic that I gave demo to share, and I thought that you were in the in the schools, and the same topic is going on chapter number 8. But you're able to
We
understand,
we
huh?
don't go to the same school.
Okay, same topic is also not going on.
No.
That you should have mentioned. I spoke to Sharon's mom about it. All right,
Hmm.
doesn't matter. We'll continue. But you're able to understand, right?
Yeah.
Okay, so general formula is CnH2n plus 2. Don't worry, we'll not go on for writing structures, etc. That is more complicated. I'll just talk about general formula and finish up with the naming of alkane. That's all. Now, here N symbolizes number of carbon atoms. You'll be able to do this, don't worry. Number of carbon atoms, right? And N has to be greater than equal to 1. At least minimum 1 carbon you have to have, right? Let's do example. If suppose N is equal to 1, can you put the values here? C becomes 1 and
One,
H becomes how much? Substitute 1 here. How much H will be there? How many H?
4.
4. Fine. If 1 is there as subscript, now when you have any element, let's say X, these positions are called subscript and these are called superscripts. This is subscript on the right hand side, subscript on the left hand side, superscript on the right hand side, superscript on the left hand side. All right. So if your subscript is 1, we ignore, we don't show it. So this is written as CH4, right? If you have N is equal to 2, tell me what will be the formula? Substitute 2 here. C2H.
C two H6.
Good. If it is 3, then
C3
yes,
H8.
H8. Very good. If it is 4,
C4 H10.
very good. 5
C5 H12.
and 6.
C6 H14.
Fine. Until 6 carbon atom, you have the molecules in your course. Your course says that till carbon number 6, you should know alkanes, you should know their names, you should know how to write their structures, and you should know how to write their isomers if possible. That's your VCE syllabus, right? But
Yeah.
are you able to write down the molecular formula? Look, this is called molecular formula, MF. How many atoms are present, right? It's a formula which tells you in a molecule how many atoms of individual element are present. You can look at CH4 and say 1 atom of carbon and 4 atom of hydrogen are present. And this is the molecular formula of methane. How do I know it is called methane? Why this is called ethane, propane, butane, pentane, hexane? This I'm going to teach you now. The whole purpose of doing this is you should know N should be greater than equal to 1. At least 1 carbon atom you should have. If it is 1 carbon atom, the molecular formula is CH4. All 4 bonds of carbon are satisfied by hydrogen, and this is called methane, right? Have you ever heard about this compound?
Yeah.
All right. Now I'm going to talk about naming them. Okay, we'll finish after naming. Okay, we'll not go ahead because you've not done this topic, right? So I'm going to talk about nomenclature. That's called IUPAC name. This is very, very important. What does that mean? Let's say, Henna, your mother calls you, let's say, sweetie at home. Your father calls you like bunny. Fine. You have, if in case you
Yeah.
have a sister or brother, they call you like Big B, something like this, something they call you like this. But suppose you go to school, nobody calls you by those nicknames other than maybe your friends. Your teacher or your principal will always call you by your official name. So that if you come to India or you go to UK or you stay in Australia, any place, everybody will know you as Hannah, right?
Yeah.
The same thing happens with CH4. Let's take the simplest hydrocarbon. CH4 is called as the simplest hydrocarbon. So what is IUPAC? Let me explain by giving you this example. Long time back, when there was no IUPAC system, I'll give you what is the meaning of IUPAC a little later. Long time back, when there was no system, it's just a theoretical story I'm telling you. CH4 was called as, let's say, marsh gas in India. Somebody called it by, let's say, X in, let's say, US. Somebody called it as Y in France. You know, now when all, this is your earth, when all the chemists got together, and they wanted to talk about reaction of CH4. Indian scientists started saying there is one marsh gas, it reacts with so and so. US people did not know that CH4 is marsh gas. They said, no, X reacts like this to give you this. France people had no idea what they're talking about. They were saying that, no, Y reacts like this to give this. Since different people or different chemists were knowing a compound by different names, it led to confusion. So then, I for International Union of Pure and Applied Chemistry, a committee was formed with chemists from all over the world, renowned chemists, and they decided if there is a compound called CH4, it should have only one official name, and that name is called as IUPAC. Now, the difference between human name and chemical names are henna can be tens and thousands. You can have henna in India also, you can have henna in US also. Same name, same surname can be there for so many people in the world. But as far as chemistry is concerned, no two compounds can have the same IUPAC name. You will have no compounds with the same name. If in case you have two compounds with the same name, then they're just one compound. They're not different compounds. Is that clear?
Yeah.
So IUPAC means official name. Official, we'll not use the word official, we'll use IUPAC name. Some people call it as IUPAC, some call it as IUPAC. Depending upon what your teacher says in school, you can follow that. It's called as IUPAC
Yeah.
or IUPAC. Follow what your teacher teaches you in school. Is that clear? So
Yeah.
it is very, very important that you learn nomenclature. Nomenclature is your ability to name any compound. As you move from class 9 to 12, 9 to 10 to 11 and 12, you will be able to name at least thousands of compounds. It looks difficult right now, but you will be able to name thousands of compounds as you move ahead in your higher classes. All right. So I'm going to teach you
Yeah.
what is IUPAC name. IUPAC name has set of rules. Everybody has to follow rules. Who made these rules? This committee made rules that you're going to do this first, find out this, do this, and then name. These are the names which a compound has. So let us begin with IUPAC name of alkanes, and we'll stick to only 6 carbon atoms, okay? IUPAC names. For alkanes, I'm going to teach you just basic. IUPAC name will consist of two things. One, word root, and second, suffix. In your books, word root is given as prefix. Later on, this will be incorrect. So I'm going to teach you there's something called word root and something called suffix. If you add both, you are going to get IUPAC name for alkanes. Now for alkanes, the suffix is always, you can learn this with me, okay? Suffix is always this part, ane. So what is word root? Word root, it's like a root. Number of carbon atoms in a compound gives you word root. Right now, for simplicity, let's say if you have number of carbon equal to 1. What is the molecular formula? How to find molecular formula? CnH2n plus 2, that's the formula. Substitute 1 here and we have CH4. If you have one carbon atom, you need to learn that the word root is meth. Learn it with me. Meth. And since something has to be added to meth, I'm putting a dash here like this. Right? If you have two carbon atom, can you see? The word root is eth, E capital. You have to learn this. You have to cram this actually. Eth. Is that clear till here?
Yeah.
If you have three carbon atom, C3, this should be, I'm so sorry, C2H6, I'm sorry. C3H8 prop. If you have four carbon atoms, C4H10 but. These things you have to learn. After that, we are going to follow the Greek system. Greek means 5. You must have learned in mathematics pentagon. Pentagon means 5 side. So
Yeah.
pent. And if you have 6, we'll keep it C6H14 hexagon. Alright? These are special names.
Yeah.
1, 2, 3, 4. Thereafter, you have your Greek systems. As we move to higher classes,
Mm.
you will learn carbon number 20 is called by some other name, carbon 30 by some other name, but that is beyond your level right now. So learn this. If you have one carbon atom, meth, eth, prop, but, pent, hex. Is that clear?
Yeah.
Now, you know that these are all alkanes. These are all alkanes. So, what should be the suffix for them? I told you just now, ane.
Yeah.
Now, add meth and add ane. Let's talk about the IUPAC name, IUPAC name. Look, if you have CH4, it has one carbon atom, the word root is meth, plus suffix ane because it is an alkane, combined together and you have the official name methane. One word, no gap, first alphabet capital. Am I clear? One
Yeah.
word, no gap, first alphabet capital. Now, if you have C2H6, you have two carbon atoms. So, eth, suffix is ane, your IPEC name is E capital, no space, ethane. Did you get this?
Yeah.
Now tell me what should be the name of C3H8?
Propane.
Propane. Very good. See, you have not done this chapter and still you have been able to recall. What about C4H10?
Butane.
Very good. First alphabet capital. In your books, first alphabet has been given as small. No. Always you have to keep the first alphabet capital. That's the rule. Butane. Then it is pentane. And then it is hexane. Is that clear?
Yeah.
Now I'm going to ask you a question. Before that, let me tell you if you have 7 carbon atom, the word is hept. Am I clear?
Sorry?
If you have 7 carbon
Heptane.
atom, the word root is hept.
Heptane.
This much is clear?
Yeah.
Now the
Yeah.
question. Now you
And
will do this. You have a pencil and a page or a book. Tell me
yeah.
the alkane, the IUPAC name. Tell me the IUPAC name of alkane where N is equal to 7. Also tell me the molecular formula. Tell me.
Molecular formula
Tell me.
will be C7
Mm-hmm.
um, H16
Very good. And what should be the name? IUPAC name?
heptane.
Heptane. Very good. H capital. Okay.
Yeah.
Right. Any questions?
No.
I'm really sorry. I was not knowing that this topic has not been taught to you. All right. But were you able to understand?
Yeah.
Okay. Should I proceed ahead or are you satisfied with the demo?
Yeah, you can proceed.
Okay. Shall I ask one question from your mama also? She was sitting and watching.
Yeah.
So one chemistry question for mama also. Shall I?
Sure, yeah.
Okay. Okay. Tell me an alkane with carbon atom 3, the molecular formula and the name. Hannah, no help. Don't look at mama. Look at me. Anna.
Three
Sri.
is propane
Wow. I'm going to take your mama in my class
and
now. Molecular formula?
C3H8.
See. What's your background, ma'am?
I'm actually into IT.
Okay, you're also into IT. All right. See, your mama has no background of chemistry. She's able to tell hydrocarbons. Okay. See, it's really lovely to see that you let your mama sit. Most of the students ask their mother to go away.
No, in fact, she was telling me to go away. Said
Oh,
it's the demo class. So I'll
okay.
just sit in.
See, it's lovely. Okay. So I'm another 10 minutes. I'm going to teach you the structures then. All right. I'll teach you the structures and then since you're able to understand, we can continue further. Now we'll talk about, we've done this. We'll draw structures of alkane. You've done the molecular formula, right? Now how to draw the structures. Before I teach you structures, you have to remember carbon has 4 valencies. Remember this, tetravalency, okay? Now let me draw something like this. Just listen, okay? 1, 2, 3, 4. All right. If I number these carbon atoms, let's say 1, 2, 3, and 4. I've numbered them from LHS and I'm moving to RHS. But you have a choice. You can number from right hand side here 1, 2, 3, 4, and you can move towards left hand side. Hannah, this much is clear?
Yeah.
All right. Now, I have not shown the free valencies. You will tell me how many free valency carbon atom one has. We are going to follow left to right, okay? How many this carbon has? One. Free valencies.
Three.
I didn't hear you.
Three.
Good. Carbon number two,
Two.
three,
Two.
and four.
Three.
All right, very good. Now, very important thing. As you move from left to right in a compound, in a structure, or from right to left, which one we are going to follow, left to right or right to left, that we'll learn later on. A rule will come. Right now, for this structure, as you move from, let's say, left to right, we'll follow this. You see, we are moving in a continuous manner. I'm moving from 1 to 2 to 3 to 4 carbon atom. Did I have a choice of two routes at a time? Two routes means I can go this way and any other way. No, it's just one straight chain. This is called continuous chain. You'll understand, don't worry. You'll understand. Continuous chain of carbon. What if I have something like this? 1, 2, 3, and 4. Right? If I number them, use just one pen. 1, 2. Look at carbon atom 2. I am moving from here, left to right. I'm moving here. Now I have two options. I can either go down or straight. Can I say at carbon atom 2, I have a branch? You understand the branching? I have two roots.
Yeah.
This is called branched structure. Okay? This is called continuous chain, no broken chain. Here I have a broken chain means I have two ways. I can either go straight, I can go down. This is called branched structure, a branched hydrocarbon. Now you will tell me what about this one I'm drawing? Is this branch or continuous?
Continuous.
Cut, very good. Most of the people feel it's branch. Just see 1, 2, 3, 4. I can pull this up here, pull this up here. It'll look like this. Again, you tell me, let's say 1, 2, 3, and 4. This one, branched or continuous?
Continuous.
Fine. 1, 2, 3, and 4. I can go like this. I can pull this here. So clear with what is a continuous chain, you're clear with what is a branch chain. Right? Now I'm going to move ahead. Let's talk about drawing the structures now. Simplest alkane is methane. Now you understand when I say what is methane? CH4,
Yeah.
that's the molecular formula, and the name is methane. No compound other than CH4 can be called as methane. Now teacher says, draw the structure of CH4. Draw the structure, show the bonds of CH4. What we are going to do? We'll have carbon in the center. We know carbon has four bonds, four valency, okay, tetravalency. One, two, three, and four. Now, you know these valencies can be satisfied by another atom which is present in the molecule. We have only hydrogen. How many? Four. Let me put one hydrogen here. Hydrogen is monovalent. It only wants one electron. See, hydrogen is like this. It has just one hand. So it's holding one hydrogen is holding hand with this carbon atom. This you will learn in bonding also. Another hydrogen here, another here, and another here. Just check. One carbon C, perfect. Four hydrogen this. This is called the structure of methane. Tell me, is there any other possibility of drawing the structure of methane? No possibility. We cannot have like this C, H, C here, H here, then H here, one H here, and one here. No. Carbon has to have four bonds. One, two, three. Its four valency is not complete. Hydrogen can only form single bond. Right now it is forming two bonds. Not possible. This structure is incorrect. So the structure of methane is very simple. Now when you are going to study bonding or when you move to higher classes, this is going to be shown like this. Carbon in the center, one hydrogen here, one like this. You might not understand right now. It will be shown like in 3D because you will learn CH4 or methane has a tetrahedral structure. You don't have to worry about it right now, but if you open your books, you will be seeing that all the structures are drawn like this. Fine. This looks like a tetrahedron. If I join this, you're going to see that it resembles a tetrahedron. This angle will be 109 degree 28 minutes. All this later on. Okay. So don't panic when in your books you see structure of methane given like this. This is more correct way of drawing, but we are going to write structure like this only when we become experts in writing structures like this. Others will get confused and we will stop practicing organic chemistry or will develop a dislike for the subject. We'll do with simple things and slowly we'll move on to this. All right. As we learn bonding, we'll come back to this one. All right. Even if you draw this, teacher cannot deduct your marks. This is absolutely correct. Till here it is clear?
Yeah.
All right. Let's move on to the next member of the group. The next member is ethane. Carbon atom 2, eth, ane means an alkane. C2H6. Right? I have to draw the structure of ethane. I'm going to draw one carbon and one carbon. First of all, draw the skeleton. This is called skeleton. Skeleton means you are just drawing only carbon. All right. So carbon has four valency. One, two, three, four. This is number one. For number two, one, two, three, and four. I have to satisfy the valency with atoms that are provided. I have six hydrogen. Begin with here. One, two, three, four, five, and six. So this is the structure of ethane. Any other possibility? You might say, okay, let's make it like this. One carbon atom here, second here. No, it's one and the same thing. You start from left to right or right to left. You have just two carbon atom and both carbon atom have same number of hydrogen. So this is the
Yeah.
structure of ethane. Let me condense this. How do I condense it? I write C. It is bonded to three hydrogen. Then this bond. Again, C, this is bonded to three hydrogen. So I am not showing these bonds. I have condensed the structure. It's called semi-structure. In your book, it's given as semi-structure. Right? Next comes propane. It will get complicated a little bit. Let's move on to number three, propane. Henna, tell me the molecular formula of propane.
C3H 8.
Okay. Right? Again, we'll draw the skeleton first, only carbon. 1, 2, and 3. Then the bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. I have 8 hydrogen. Let me see, are the valencies getting satisfied? We know it's alkane, so you can only have single bonds. Hydrogen here, hydrogen here, hydrogen here, and this one. Fine. Is there any other possibility? Now, what does it mean, any other possibilities? Let's find out. I have a continuous chain 1, 2, 3. Can I have something like this? 1, 2, 3 like this? I'm not showing the bonds. Tell me, will structure number 1 and 2 be same or different? Okay, let me put
Uh,
hydrogen also. 1H here, hydrogen and hydrogen. Now tell me, 1 and 2 are same or different?
they're the same.
Same, because I've just bent this like this. I can pull it here, it will become same. So these two structures are same. Any other possibility? There is no other possibility. Let's move on to number 4 and we will now see there are possibilities. So I'm taking you to number 4, butane. And once I finish this butane, I'll wind up the lecture. Butane, tell me the molecular formula.
C4H10.
Good. Now see. Let's draw number 1 structure. 1, 2, 3, and 4. Right? Again, satisfying all the valencies with hydrogen. You will require more of practice. I already know this. So I'm just putting it like this. This is one structure of butane. Let me number this. 1, 2, 3, and 4. I'm following from left hand side to right hand side. Let's find out, is there any other possibility of the structure? Just see. We should have 4 carbon and 10 hydrogen. We cannot increase or decrease the number of carbon or hydrogen. Let's look at structure number 2. 1, 2, 3, and 4. Let me go like this. Fine. Tell me. And shall I write hydrogen in condensed form like this? You understand this?
Yeah,
You get this now? Now tell me. Structure 1 and 2, are they same or different?
they're the same.
Same. Let me condense this also. This is similar to CH3, CH2, CH2, and CH3. So they are same. I can pull this CH3 here and I'll get the same structure. So this is not an isomer. I'll talk about what does it mean. Let's put up another structure. 1, 2, 3, and the fourth carbon I'm putting it here. Right? Now satisfying the valency. 3 hydrogen here, 1 hydrogen here, 3 here, and 3 here. Let me count. Number of carbon should remain 4. 1, 2, 3, 4. And hydrogen should remain 10. 3, 3, 6, 3, 9, and 1 more 10. Now, are structure 1 and 2 same or different?
They're the same.
They are the same?
They are?
You sure? Let me start walking from left to right. 1, 2. Look at 2. I can go 3 here. I can go 3 here. I have 2 possibilities. The branch structure, they're not same. Here, your longest possible continuous carbon chain was of length 4 carbon. Here, your longest possible continuous, now remember all those words that I've told you. Longest possible continuous chain without break is 3 member. Did you understand this?
Yeah.
This is called chain structure and this is called branched structure. The beauty of these structures are that they have the same molecular formula C4H10. And I said if they're the same formula C4H10, the name is butane here. Even this has the same molecular formula C4H10. But now I can't call this structure butane. Let us see what we are going to call this. It's a little complicated. I'm going to just pick up this one, all right? Shall I? If I make you understand here, you'll be able to see. Let me use a blowing. Now look, this one is called as butane. 4 carbon atoms are there. and suffix is ane because carbon carbon single bond, and the name is butane. Look at this one. At number 2, you have this group. Do you have any idea about alkyl group?
No.
No, so we'll leave it here. This the nomenclature will be different. Just remember, just see that this structure and this structure are not same. This is chain structure and this is branched, but they have the same molecular formula. Such compounds that have the same molecular formula but different structures are called as isomers. Iso means same, mers means unit. They have the same molecular formula. C4H10 for number 1, C4H10 for number 2. But the structure is different. This is your straight chain and this is your branch chain. Such compounds are called isomers. So we saw that for methane there was no isomer, for ethane there was no isomer, for propane there was no isomer, but for butane there are two isomers. Since they have the same molecular formula but different structures, they are called as structural isomers. Okay? Isomers, since the structures are different, they are called as structural isomers. Clear? I'll wind up here. If you have any questions, please ask. Okay. You give me a second. There's someone at the door. I'll just open and come. All right, Hannah. Any questions from the topic that I've taught you?
No, not good.
This is good. All right. Anything else?
Oh, no.
Okay. Then you can just let me know through message or a call, right? Fine. So,
Sure.
Chala, I wish you
Yeah.
all the good luck. Thank you so much. Okay. Bye bye.
Thank you. Thank you
Welcome.
so much for your time.
Welcome. Welcome.